Okay, now we're going to talk about Proxmox. Proxmox is a commercial open source kind of distribution. It's available for free for use by users, and there is paid commercial support as well. So this is really a product that is leveraging KVM, QEMU, and LXC under the hood. So everything we talked about in the previous video of this series that focuses on KVM, LXC, Linux bridges, and OBS applies to this product as well. What they have done is create their own API layer as well, so they can interface directly into the creation of bridges, so networking constructs, which is something we can't normally do with libvirt, and all the way up to the creation and maintenance of virtual machines, migrations, etc. So this is built on a foundation of the same tools we talked about previously, and it's been adapted to make it more consumable by the end user. Now, this product doesn't have an isolation capability native into the product set as of yet. I have submitted a patch, or had engineering actually create a patch for this, which has been made available. I've productized this a bit with a script on my GitHub repository, and I'm really hoping they push this into a production build of this software at some point as well soon. So I think this is a valid option for customers that are happy to reside on a Linux-based platform, and it should scale really in the same manner as every other Linux-based platform would as well. But it's probably more targeted, I think, initially at the lower end, smaller end of the enterprise sort of market as well. So I've got a very similar build to what we had in our previous settings, but you'll see that all the CLI commands have gone and been replaced with some GUI constructs here as well. Right, it is using Linux, Linux Debian actually as its so the commands we have available to us from a networking perspective are very similar. There is actually their own user land tools as well. But if I look in here, and we have the same basic networking stack that we're now sitting on top of, but it's been abstracted away with a GUI. So we'll jump into the web interface for it, and I've got an interface I'm going to use here, this ENO0 interface. So look at the interfaces that are on here. We've got this ENO0 interface, which is currently up. They have a feature inside Proxmox called SDN, and SDN really is just the orchestration of bridges, whether they're OBS or Linux bridge, across multiple different managed hypervisors. So it allows you to configure a distributed switching model. If you're running OBS, you can also connect them together using VXLAN and EVPN as well. And it uses free-range routing under the hood for its routing stack, which coincidentally is the same as what VMware NSX uses as well for its routing stack. So it's based on a very similar heritage and a well-supported software stack. So the first thing I need to do, which typically this has to be done from the CLI for other products, but here I can come and create a Linux bridge. I'm going to call it VMBR0. I'm going to put it onto ENO1. Took that as well. And then I apply that configuration. So this will push this out to the individual host. Right, so we've now got this here, right? So it's a standard Linux bridge associated with that physical interface. Right. Next thing we do is we jump onto the data center tab. So this is the name essentially of all the managed devices. If I had more than one host, it would be applying configuration en masse to all of them. I'll create a VLAN zone. We're going to call this ISO demo. I'm going to associate it with the bridge. So this bridge needs to be present on all devices that I'm selecting. So I'm going to put it onto a single node. If I had multiple nodes, multiple hypervisors, that'll all be listed here, or I could just specify nothing and it defaults to placing it everywhere, and we add that. I'll just apply that here as well. So you can see it's actually going out to the node and issuing the commands. Right, so there's no change here. It's really just a logical construct that gets pushed into that platform. Right, now we're going to make a new virtual network. So create a virtual network. I'm going to call this VLAN 10. It's going to be associated with this zone. This is essentially, a zone is essentially a VRF. If we dig into the free-range routing software stack, you'll see this actually configured as a VRF in here. I'm going to give it a VLAN tag of 10. And in this advanced section here, there's this ports isolation option, which needs to be applied using the patch they have made available. So hopefully this gets pushed into a production version. So we need to actually reload by applying or push the changes out to the platform. We see we've now got VLAN 10 here as well. So what it does is it creates a interface associated with that bridge. So VMBR3.10 using VLAN 10. So we should see it in here. Right. So really this is just applying changes to one or more Linux hosts, really using its own API. So now I've got that attached to my interface. I should be able to come here and also look at LDP. Showing neighbor ports. I think it's on 1.1.12. Cool. 0. Okay, good. So it's connected on 1.12. Oh, I need to do EN01. Right, so it's connected to that switch. Great. So any containers or VMs now that are attached to this. So I'm going to spin up C5 and C6, VM13, VM14. So I've gone through this procedure here. So now we can create our VMs. Do some containers first. So create some containers. I'm going to call this one C5. Put a password. So this is actually building the template for me. This is using LXC under the hood. We're going to use the Alpine one. Place it onto that. We're going to attach it to our newly created VLAN 10 and turn off the inbuilt firewall. I need to change my diagram because that's got the wrong IP address. It's on 161. Don't need to really give it a gateway, but cool. Let's just change these because they're wrong. Okay, it's just that one that was wrong. 151. We'll do those next. Great. Okay, that's done. Let's make another one as well. So let's make this one here called C5. Create another container. We'll call that C6. Okay, let's just create some VMs while it's in here as well. So let's do that back into here. Okay, VM13. I don't think I've got a live So, okay, we're going to skip doing VMs for a second, just use containers because I don't have pre-built ISO with the passwords and things. Okay, so let's jump into here. Okay. So by populating the address, it's actually provided it to it as well. Okay. Well, let's have a look back on switch as well. Okay, so we actually see it's assigned these interfaces here, these two veth interfaces. I've also got my same command from before. You'll see that these two interfaces are already marked as isolated, so that's what the option in the configuration here does for us. So instead of me having to run that script, it simply does that for us by issuing exactly the same command that I would have to do if there's a manual operation. So, okay, I can ping the default gateway, and I should have pinged 162. So again, that first response is a bit slow, so it's probably coming from, cool. Okay, so going back through our slides, should have pinged 41, 42. Ah, what am I doing? Graphical glitches. So 44, do we have 51? No, what was next on here? 44, 45, 6. They may not be running. No. Oh, I didn't run those ones. And then we had our Incus ones as well, so 140. It's a typo on here. 141, 142. Oh, okay, incorrect. And then one, two, and 3 and 4. Okay. Okay, so we should have quite a few entries in here. Right, so I have micro-segmentation now running inside Proxmox using LXC containers, as well as KVM essentially on bare metal, and LXC using Incus as the controller or orchestrator, and all using proxy art through here. So as you can see, tools like Proxmox are simply just residing on top of existing Linux tools and networking stacks. It simply is just provisioning things exactly the same way as we were before. The SDN layer is orchestrating across multiple hypervisors. There is some additional smarts as well, so there is free range routing running in here. I don't know if I can get onto it. I need to work out how you do it. It's been a while since I've used FRR, so I'll have to experiment with that next. Okay, great. So that's it. We'll get on to OpenShift as the next one. Thank you.